Google secretly worked for 4 years on a device able to produce safe drinking water fully off-grid, out of sun and thin air, and not only did they prove it to work, but also that it could provide water to over 1 billion people who lack safe access to it, yet they gave up developing it in 2021, open-sourced all their findings, and 4 years later, nobody built upon it. The nut they had tried to crack has since attracted investors like Bill Gates, Jeff Bezos, Richard Branson or Mark Zuckerberg, yet without much more success to date. Atmospheric water generation remains that shiny object seducing countless of the world's most brilliant minds, yet the 3 key learnings from Google's failed attempt remain unsolved today, and maybe forever. Here's the story of Google's Hydration to Everyone project and what there is to retain from it that shines a different light on the world's efforts to bring safe water to all. And yes, sorry, I'll check my phone from time to time. I expect a very important call. You may have heard of Waymo recently, as the LA protesters said it as their signature move to put them on fire. But before that, Waymo's autonomous car were considered Google's most successful Moonshot project. Google Moonshots were the brainchildren of a semi-secret R&D lab established by the founders of Google themselves, Larry Page and Sergey Brin. Their aim was to replicate the spirit of the Apollo program and to invent and launch breakthrough technologies that could make the world radically better. Google Glasses and even Google's AI somewhat come from there, yet there's one project you probably never heard of before today, and that is Google H2E, standing for Hydration to Everyone. As 2.2 billion people worldwide lack reliable access to safe drinking water, and as in some regions people spend 10 to 50% of their income on water, the Google team raised this question, and I quote, "What if we could put the power to generate daily drinking water into the hands of individuals, no matter where they live, with an affordable solar-powered device that harvests water from the air?" Yes, they knew that atmospheric water generation would always have a low output and it could not solve the water crisis all alone, but they questioned if its small, modular, off-grid and renewable-powered characteristics could fill a critical gap for communities where infrastructure falls short. So in 2017, they started working on it by defining their scope. Compiling the existing literature, they estimated that it was possible to produce 5 liters of water per day in places that combined strong sunlight and over 30% relative humidity. One of their early findings, combining global climate datasets with UN maps of populations without safe water, was that roughly 1 billion people lacking that said safe water actually lived in places that met the physical criterion they had set, which confirmed that A, there was a market, and B, the potential impact was massive. But that also meant that the device had to be affordable to people living on just $2 to $8 per day, which implied they had to target a water cost of $1 per liter, which was 1 order of magnitude lower than what incumbent atmospheric water generation technologies were capable of at the time. Aside from that, the unit would have to be sufficient for one person's daily drinking needs, off-grid, sustainable, easy to use, and scalable. For the working principle, Google didn't reinvent physics. The idea was that sunlight would heat a recirculating stream of air, creating a source of hot, dry air. Meanwhile, ambient air is drawn by a fan onto a desiccant material, which absorbs moisture from it, and as the hot stream is driven through the desiccant, it takes on that moisture, loading it with humidity. It then flows to a heat exchanger, where it cools down and condenses, producing liquid water that drips into a collection reservoir. That double airstream, the closed loop, and the use of a desiccant made the process more complex than air conditioner types of devices, but seemingly also more energy efficient. Prototype after prototype, the team also strived to use as lightweight and low-cost parts as possible, with vacuum-formed plastic pieces, which is the type of manufacturing usually used for things like food containers. That's how by 2020, the Project H2E team had proven its core concept and developed a pre-production prototype featuring a 1 square meter solar collector panel, a heat exchanger, and a small fan that they deployed on a rooftop at Google's headquarters. The prototype could produce about 3.6 liters per day under good sun conditions, and the team was confident it could further optimize this to reach the targeted 5+ liters a day. But when they ran the cost estimates, the picture shifted.
We have a problem.
The prototype outputting distilled water at this stage, so safe water but without minerals, was doing so for roughly 10 cents a liter. Quite an achievement already, but far from the targeted 1 cent. One order of magnitude far from it, actually. This highlighted two of the hard facts that are still hard to overcome today when it comes to atmospheric water generation: physics and costs. Breaking that order of magnitude difference between the prototype and the target would involve significant material breakthroughs, especially on the desiccant, and even that would stop at the absolutely perfect theoretical material and still not reach the target. To bridge that gap, you would also need to mass produce the devices so that those costs get a chance to lower as well. And as Google believed it was neither the type of company to do fundamental material research nor mass production of consumer products, it decided to kill the project in 2021. But the way they did it was unconventional. Did he call?
No, not yet.
You tell me if he does, right?
I will.
So, unconventional, I said. Indeed, they decided to open source everything. That's how you can find all the CAD designs for the prototype on GitHub, while they published a pledge not to enforce the many patents they had introduced along their research. They also extensively shared the lessons learned along the project, which is still, to this date, available on their blog. As Astro Teller, Google Leaks' captain of Moonshots, put it, "We don't always do this, but in this case we felt sharing it with the world would get benefits out faster than if we kept it an X project." Yet all I listed is not even their main contribution, as they did one more thing. In 2021, they published a paper in Nature that also open-sourced their findings on the actual addressable market for atmospheric water generation, placing the 1 billion plus people I mentioned earlier on a world map and creating Google Earth layers and a geospatial tool to assess the potential for atmospheric water harvesters. I'll come back to that one because that is also somewhat the third hard obstacle and maybe the hardest of the three. But one more reason Google gave up in 2021 is that they acknowledged that the space of atmospheric water generation was filling up with more companies actively working on it on top of the numerous research projects in universities. Not that Google would be afraid of competition, but simply because they thought others were better positioned to reach the targeted impact. Indeed, by 2021, Source, an Arizona-based startup founded by Cody Friesen, had already raised nearly $100 million of growth money to fund its own off-grid atmospheric water generation endeavors deployed in their in-house product, the Hydro Panel. Even though the concept is somewhat similar, Source's efforts were happening in parallel to Google's Moonshot and were in fact unrelated. But one thing they had in common was the backing of the crème de la crème of tech moguls. In 2020, they had already taken an investment from Breakthrough Energy Ventures, which is an investment fund backed by Bill Gates, Jeff Bezos, Mark Zuckerberg, Richard Branson, and many more. And there was more to come. In 2022, Source raised what was at that time the second largest investment round ever in water tech with its $130 million Series D. Their founder, Cody Friesen, said in the press release that this fundraise was further enabling them to bring perfect water to every person, every place, once again targeting the technology at covering the water needs of the over 2 billion people on Earth without safe access to it. On my podcast microphone, Colin Goddard, their VP North America, doubled down by stating they aimed at creating, and I quote,
"Our goal is to become by far and away the cheapest source of potable water on the planet, no matter which market we're talking about."
But the second half of that sentence is actually the third hard obstacle we need to talk about: the actual market. Indeed, when Google or Source say they aim at generating the cheapest water from air, they often compare atmospheric water generation to desalination, which is honestly a bit of a stretch. From a physics perspective, the theoretical effort to desalinate water is the same as the one to harvest water from air at a 98% relative humidity. But first, relative humidity is rarely that high, and second, while desalination technology is able to reach 30 to 40% of a perfect thermodynamic system today, atmospheric water generation is still only at 5% of its own thermodynamic perfection. So a simpler way to say this is that as of today, desalination is still much more efficient than atmospheric water generation, and it will very probably remain so. Now, on the other hand, Google or Source are right. Desalination requires a very large infrastructure, needs to sit on the coast, and then to build upon large pipe networks to bring water inland. So the more remote you get, the more interesting atmospheric water generation becomes, as it only needs a solar panel, a desiccant, and a fan. that's how, if you one-to-one compare the two technologies, you end up finding a trade-off distance of remoteness from the big plant on the shore, from which atmospheric water generation becomes cheaper. But the problem with that reasoning is that there are far more sources of safe drinking water than just desalination and atmospheric water generation. You could get your water from a well, a surface water treatment, a wastewater recycler, and many more. Spoiler, all of those will be much cheaper than both atmospheric water generation and desalination, even if, again, they rely on some level of infrastructure. But even if we go for infrastructure-less approaches, tanker trucks with water inside or bulk water bottles will still be cheaper than atmospheric water harvesters, at least today. And they can be equally remote. This is how, at least for now, atmospheric water generation companies have pivoted towards higher-end markets, with Source launching a bottled water brand and many more cool tech companies aiming more at your first world city condo than at a third world water challenge. Don't take me wrong, that pivot is a great business move and it's proven very profitable for many companies that did it. But it leaves the question of how to quench the world's thirst still unanswered. Google has tried and given up. Source is low-key still trying, but despite confirming in a recent Science article he still believes that they will eventually make it the cheapest water on Earth, Cody Friesen, the company's founder, has also left it. Now there are still incredible people working to make this world a place where we have safe water for all. That's a story for another day, but I'm told that Team Water is recruiting and that it might soon have a new coach. Oh, is he on the line? Hey, Jimmy.